Thanks for coming along. My name's Richard. I work for Underscore. Underscore is a consultancy based in the UK. We also work out the US and Australia. And I tend to work on writing software for clients and helping them with code reviews, that kind of thing. And you'll find me on Twitter as D6Y. So that's all about me. What this session's about is Scala.js. And what I want to do is describe to you what I think of as kind of an ideal world for writing web applications. Ideal for me, that is. And show you how that pans out in practice. And by ideal, the kinds of things I'm talking about are writing in a language with types, so a language like Scala. And I want to be able to run my programs somewhere that's robust and fast, so somewhere like the JVM. But we're talking about web development, so that means we've also got to be able to run in the browser, so in a JavaScript environment. And I want to do all of these things, and I want to do it without having to repeat myself, without having to worry about where my code's running, and sharing code wherever I can. And these are all things that Scala.js help with, and we'll see. And the reason I like these things, I think they're good principles, is it's very simple. I just want to make change easier. So when I'm building an application across the lifetime of that app, I want to be able to go in and quickly and safely and cheaply make changes and sort of get on with my life. And I think Scala.js plays an important part in this kind of a goal. This talk is in 3 parts. I'm not assuming any knowledge of Scala.js, and I'm just a user of Scala.js, so I'm going to run through a really quick introduction to it from my point of view. Then I'm going to introduce the example we're working with. This is a collaborative text editing tool, so you think of Google Docs, and this is a fun project because it demonstrates server-side stuff, client-side stuff, sharing code, sort of many other things I think are great about Scala.js. And in particular, we'll be looking, you would have seen in the title, we're talking about CRDTs. It's a particular type of data and algorithm, and we'll get into that in part 2, but the specific algorithm is called Woot. The biggest section, though, is where we're looking at the mechanics of this, how you structure an SBT project and how this all works out in code. And as we go through this agenda, there's really 2 ideas I want to try and get across to you. The first is you can gradually introduce Scala.js into a project. Now, you might have already seen a lot of Scala.js demos where an entire app is built in Scala and run in the browser, a game or something. And if you've not seen them, do check them out. They are really superb and impressive. But this session is not about that. This is coming from my world where you're working on a team that already has some great JavaScript developers, and you already have some great JavaScript assets. And rewriting that for the sake of it is not a good use of time or money. So you can gradually introduce this stuff. And the other point is that there are certain kinds of algorithms, distributed data types, which are, well, they're immensely fun, and I think they're a really good fit for Scala.js, and that's going to make more sense in part 2. So let's take the quick introduction to Scala.js, and if you're totally new to this, how many people here are totally new to hasn't written a single piece of code that uses Scala.js yet? Okay, so you need to get over to Scala.js.org. Hold on, put your hands back up again. How many was that? That was 2. Okay, it's all of you. Right, fine. So you need to get over to Scala.js.org, and there's a really good tutorial here. It'll take you like half an hour to work through the tutorial, and you'll get a really good idea of what Scala.js can do. So do that. But what this website is also telling you is that Scala.js is a Scala to JavaScript compiler. So what does that mean in practice? It means you go away and you write some Scala code. And there's a plugin to SBT, like all the other plugins and it will result in some JavaScript code, which you can then put on a web page and use. But of course, you don't just write Scala by itself. You use the standard library. You maybe use third-party libraries as well. And Scala.js has a solution for dealing with those things too. So you can use some of those. And on the browser side, you'll want to use the DOM. You'll want to use jQuery, React, Angular, all those kinds of things. And Scala.js has, the community really provides bindings for some of these JavaScript libraries. So you can write Scala code and make use of the W3C DOM you all know and love. And what's maybe surprising about this kind of simple picture is, well, it kind of covers all of Scala, which is still seems to me kind of miraculous. But you don't get Java, right? It's the Scala to JavaScript compiler. So, well, the example I use at this point is to say, so, you wouldn't expect to be able to use JUnit, a Java library, right? And you wouldn't expect to be able to use a Scala library that depends on JUnit. Unfortunately, I need to work on a new example because JUnit is now being ported over. But the general principle is don't expect sort of arbitrary Java to be supported. We're focusing here mostly on Scala. That doesn't restrict you very much because you can use Scala-Z, you can use Shapeless, you can use Scala check. There's a whole bunch of things that are being cross-compiled to the JVM and JavaScript. And there are new libraries appearing. So Scala tags is a kind of DSL for markup. Microtest for unit testing and micropickle for serialization. And these are new frameworks, new libraries that are built from the ground up for Scala.js and the JVM. And as I mentioned, there are various typed bindings that you can use for React and JUnit. And over the weekend, in my mailbox, I see someone had put some bindings in for Google Maps as well. So it's an ongoing, growing community there. So to use Scala.js, it's actually pretty simple. There's a plugin that I mentioned. You include that in your build. And you incorporate the settings from the plugin just like you would any other plugin. And you go away and you write Scala code. The only kind of special thing you need to worry about here is you mark the entry points into your code. So this is what you're exporting to JavaScript, if you like. And you do this with an annotation. And the point of this is so the compiler can throw away all the standard library you're not using. So you end up with a much more minimal sort of JavaScript file at the end of it. There's an SBT command called fast.js that gives you the JavaScript file, and then you can just include it. There's no additional kind of runtime you need or anything special like that. It's just a JavaScript file. We should look at what's in that file, maybe. So here's a kind of very simple Scala method. It's constructing an option and mapping over it, nothing exciting there. And the JavaScript produced from this, well, it's not exactly this, but it's kind of like this. So we end up, it's kind of doing what you might expect, I guess. Our methods are function in JavaScript. The Scala.js compiler realizes when you use option, so option comes over and checks if it's empty, the result's none. If it's not, gets the value out, applies the function, stuffs it back in a sum. I think this is not too weird for what you might expect. And the real output is not much longer. It's a little bit weirder with the names. And there are a bunch of optimizations in here that the compiler's doing that I don't have to know about, which I'm very grateful for. And normally I wouldn't look at this stuff at all, but I just want to show you that it's fairly reasonable kind of output. So the sort of selling features, if you like, of Scala.js is that you get this kind of nice, fast compiler during your development work, and then there's another one which works a bit harder to compact down your JavaScript. And the resulting JavaScript is pretty fast. But the main point that I want to talk about really is it has great interoperability with JavaScript, which is when you're working with existing JavaScript assets is really, really important. And I've put the last point, community, should probably be the first point, that there's this ongoing effort to support cross builds on Scala libraries you know and love, and producing these new libraries and new bindings. The last thing I want to say, just to introduce Scala.js, is that it's not a framework. So if you're familiar with something like GWT, or it's not a GWT, and it's not a web framework like Angular. It's a Scala to JavaScript compiler. And what you do with that is kind of up to you. What we're going to do with it is build this collaborative app. What that's going to end up looking like is something like this. So this is a web browser with a sort of souped-up text editor in it, and we're using an existing JavaScript editor called Ace. So ACE already exists. We don't need to write any of this. What we're going to do is add collaboration to it. So we're going to have a bunch of people all sharing the same document. And when I'm talking of sharing a document, I don't mean like screen sharing. This is, in fact, everyone has their own copy of the document. And as you make an edit, your copy diverges from everyone else's copy. And the trick of this game is to make everyone converge to the same text. To do this, there's going to be a server as part of this. I'm using HTTP4S, but it doesn't matter for the point of this talk what that is. This is where you go to join the documents. This is where you go to start editing, and all messages are going to flow through this server. So when I hit a key on my keyboard, my editor is going to instantly update, of course. That's going to pass my change to this Woot algorithm that's going to deal with consistency for us. That's going to produce a message we can send across the network. And the server's going to consume that edit into its model and maybe lazily save it to disk or something, and then broadcast out the edit. Every client is going to have to do exactly the same thing as the server. It's going to have to incorporate this edit into its own model and update your display. So you can see why I like Scala.js. I have to have the same algorithm on the server and the client. So the real question with this, the kind of interesting algorithm part, is what should these messages be that fly around the network? How hard is it to write a collaborative text editor? I just want to show you that it's not super trivial, and it's very much worthwhile investigating something like Scala.js for this stuff. So this is what you shouldn't be doing. This is like the naive approach. Here we have two people, Alice and Bob. They're taking a day off from cryptography, and they're working on a document about cats. So they're both sharing a document that has the word cat in it. And what Alice is going to do is insert a letter H at position 2. She's going to end up with the word chat. Pretty straightforward. Meanwhile, Bob's going to delete the last character, that T. This is fine. Nothing's gone wrong yet. They've made those edits simultaneously. And now they're going to exchange messages across the network. And they're going to end up with different results and not even know they've ended up with different results. This is a disaster from a collaborative text point of view. And the problem here really is that Alice had the word chat, and she received a message saying delete the third character. That's not a T anymore. That's not what Bob intended, and we've ended up with different results. So this is just to illustrate really quickly that you need something more sophisticated here. And if you're going to write something more sophisticated, you don't want to duplicate that effort. So the solution to this is a commutative replicated data type, a CRDT, and this is a very general class of algorithm. It's not just restricted to text editing. And it's the general problem where you have distributed data and you've got messages passing around. You can't control the order, but you need consistency everywhere. You'll be looking towards a CRDT. So we can unpick this for our case. We have replicated data. Everyone has an editor with a copy of the document in. And we want commutative behavior here, right? Just like addition is commutative. If we are all adding up the same series of numbers, wouldn't matter what order you got them in, we'd definitely get the same sum. And we want the same behavior with edits. It doesn't matter who deleted what when. At the end, we want the same text. And that's what Woot does for us. Now, in truth, we don't need to fully understand the details of the Woot algorithm for this talk. There's one case class and two functions I want to walk through. The quick introduction to Woot is, well, how does that scenario play out? Well, the trick is that we have a different representation for the edit. We don't talk about positions. We're talking about Alice inserting a character between two others. And we're talking about Bob deleting a character. Now, a character here is not just an ASCII character. It's something richer than that, and that's where the magic comes in, pretty much. But these are the same edits, but when we exchange them, we get a consistent result. And the reason we do is that Bob has a C and an A in his buffer, and he receives the message, put an H between C and an A, and he can do that. Likewise, Alice receives the message, delete a T. She has a T. It can get deleted. That's the sort of gist of the algorithm, what happens. These characters, though, is something we call a W char. It's much richer than a character. And this is going to be a case class in a minute. So this character you're throwing around the network is made up of 5 parts, and this solves a lot of the consistency problems we might have. So the first part's a globally unique ID, which you can get really cheaply. It's made up of 2 parts, like something globally unique, maybe it's your username, something you get when you join the document. So we call it a site ID. And then a local clock, which is, I should just call it a counter, because what happens is when you hit a key on your keyboard, your local clock increments. You can concatenate it with the global part, and you've got a very cheap, unique global ID, which is also ordered as well. And when we talk about inserting characters between 2 other characters, that's what previous and next are for. They just point off to other IDs. And there's the 4th part is the character itself, of course, the payload. And another kind of interesting point about Woot is it doesn't ever delete anything. It just marks things as invisible. And that's an important point. And the way the algorithm works, I'm not going to go through the code for the algorithm, but you can think of text as a kind of graph. So here we've got 3 people editing the document A, B, C, D. And you can see that as a graph that goes A, B, C goes to D. And what the first person's doing is inserting a C between X and D. And that gives us a new graph. And the second person's deleting a character, which we know just makes it invisible. So I don't know if you can see it, I've put a line through the B, sorry. And the last person's inserting a Y between B and C, which we can do, right? Because it's not deleted, it's merely hidden. And the intuition I'm trying to get across here is that it wouldn't matter what order we apply those edits to, we'd end up drawing the same graph. And that's kind of the gist of the algorithm, and that's what gives us this commutative behavior. So how hard is this to implement in Scala? It's about 200 lines of Scala code. It's not too bad, actually. And once you've done that, you can run this code on the server. But I want to run it in the browser, right? That's my ideal world. So how hard is it to write in JavaScript? Well, I've done that as well. It's not too bad, actually. It's about 200 lines of code. And once you've done it in Scala, you have to change the way you think a bit, but you can basically bang the code out in JavaScript. You're going to pull in a few libraries to help you. But if you do that, you now have 2 problems. You now have 2 sets of source code to maintain, you have 2 sets of tests to maintain, and you have to worry about interoperability between those 2 worlds. And this is the opposite of making change easier. This is making life harder. So you can see why I like Scala.js. It basically roots around this whole problem by letting you implement something once. So there are lots of bits of Woot we could look at in terms of code. I'm going to look at 2 places, 2 functions. The first is the local insert function. So this is when you are tapping a key on your keyboard. That's going to take your consistency model, this Woot model, which I've called a W string here, because it's made up of W chars, and the edit you made, and it's going to give you back this 5-value W char to send around the network, and it's going to give you an updated model. And when you receive one of these things across the network, that's the other function. We've called it ingest here. And that just takes the character you received in your model and gives you back a new model. Those are just the 2 functions we're going to look at, and that's going to cover a lot of JavaScript interoperability here. So we're going to migrate this algorithm and the data structures over to Scala.js. So I showed you this diagram earlier of what we wanted to build. And I'm going to focus in on the kind of vertical stack of elements here. And if we do that, we can split it out between browser-side stuff and JVM-side stuff. So at the top there, there's the editor user interface. That's written in JavaScript. As we go down, you can see there's a whole mix of technologies here. And the point of this is to illustrate that Scala.js plays nicely with others, which is vital if you're gradually adding it into a project. So the editor, as I explained, is backed by this core consistency algorithm, this Woot model. That's going to be written in Scala.js. That's going to we're going to take the results of this character, and pipe it around the network down a WebSocket. And that's going to be just a bit of JavaScript code. We could write all of this, in Scala.js, but that's not the point of this talk. This is to say, you can reuse what you've got. We've got this stuff already. And on the server side, we're going to consume and edit. That's going to come across the WebSocket as JSON, and we're going to use some Scala.js as well to deal with that. And we're going to, on the server side, update our consistency model. So that's basically what we need to build. One slight addition to that, I'm going to put a little client wrapper around the Woot model on the client to solve a problem I'm going to tell you about in a couple of slides' time. So another way to look at this diagram is to split it out into what runs only on the client and what runs only on the server and what's shared. So the stuff on the left, that's just client-side stuff. Okay, the editor is only going to run on the client. The little client wrapper is only going to run on the client. That WebSocket JavaScript we've got, we're just going to run that on the client. The Woot model is what we're going to share, and this gives us the structure we need for our SBT build. So the SBT project you're going to create is going to have, well, it's going to have two projects in it. It's going to have a server-side project for the JVM, and it's going to have a client-side project targeting JavaScript. And both are going to depend on the stuff we're sharing here. And if you're thinking at this point, a multi-project build with shared dependencies and some weird SBT plugin sounds a bit scary, I think your intuition's about right for that. It's obviously no problem for SBT gurus. But for the rest of us, it is a bit of a stumbling block at first. I will kind of admit that, I think. But don't stop here. This is definitely something you can get over. Scala.js.org has an example on it, and I'll put this code out later as well. So don't stop here, get past this, and you'll see that a lot of the commands you know and love are already available. So you can compile these projects. On the server side, you get class files, you know that. In the client projects, you also get these Scala.js intermediate representation, which is it's kind of unlinked expression of the JavaScript, but it's not actually JavaScript at this stage. You get JavaScript from this fast.js, and that produces a JavaScript file you can use. It's quite large at this stage. For this project, it's about 1.5 meg. That's fine for local development, but obviously not something you want to ship. What you then do is you spend a few more cycles running full-op.js, and that produces, in this case, about 295K before any kind of gzip or anything like that. And that's absolutely totally fine for me. For your use case, it may be too big, or you may not care, I'm not sure. So you spend most of your time probably in something that will run fast.js somehow. That's the structure of your build. Don't get hung up on it. I can get past it. You can get past it. But whilst we're on the subject of the build, you can obviously depend on third-party libraries too. So I'm depending on Scala Check, which is a properties-based testing framework. If you're not using it, you should be using it. Take a look at it. And you depend on these with this, I don't know if you can see that, there's a triple percentage sign up there, rather than the double percentage. Double percentage, you're familiar with an SBT, it allows SBT to pull down the version of a dependency for what version of Scala you're using. The triple percentage lets SBT pull down the right dependency for whether you're in a server project or a client project, for JVM or JavaScript. What this now means, though, is that I can run a test, and I can run it in the server on the JVM, or I can run it in a client environment on Node or Rhino or whatever you've configured. So not only can I share an implementation, I can share the tests for that implementation, which is a huge saving. So let's look at, we've spoken about build, let's look at some code. Remember this data structure from earlier? So we can represent that as a case class. So the only weird thing I've done here is mark the case class as being exported with this JS export annotation. And what that's going to do is when I run fast.js, it's going to produce a JavaScript file. And I can include that JavaScript file in some HTML. And then in JavaScript, I can call what I've exported. I'm slightly embarrassed that this is incredibly easy and really straightforward. So you can do that kind of thing, and it works. We can do better in this case, though. So there's a couple of problems here. One is that this whole API, next and previous and IDs and all that stuff, I think I expose a much easier interface to the JavaScript team to make use of that. And the other thing you might not have spotted is in the case class, I declared the character as a byte, which is clearly wrong. Okay? It should be a character. What on earth was I doing? Well, it's actually a compile error to expose a char like that directly. And to understand why, we just have to touch on very briefly on the semantics. of Scala.js, and semantics are that of Scala, which is a wonderful, wonderful thing. It means you can be writing Scala. You don't have to be thinking too much about where it's going to run. But there are some differences. So one of them is that JavaScript doesn't have a char representation. In fact, it doesn't have a representation for long either. So you've got to decide, if you're exposing it, what you want to do about that. So in our case, we just can treat it as a string, right? It's the obvious thing to do. But there might be other encodings that are relevant to your particular use case. There are also some differences the way floating point numbers are turned into strings, but not something I've run into. But if you think the way I think and you look at the list of differences, you'll be going, oh, that's it. There's really not many at all. So we can get round the char problem, and we can get round making the API nicer by just providing this client wrapper I mentioned. So here what I've done is created a regular class, and I've exported it. So this will be visible in my JavaScript. And I've also created two simple methods and exported those. This constitutes the entire API that will be visible from JavaScript. So I kind of simplified things here. You'll also notice this client has a little bit of state in it. That's the document itself, this W string thing that's made up of lots of W chars. So Scala.js has figured out, obviously, to complete this code, it needs to bring that, sort of chunk of library into my JavaScript as well. I haven't had to mark that as being exported. I just have to mark the entry points. So let's work through a couple of implementations of these methods. So we'll start with the insert methods. That's when you hit a key on your keyboard and you get a character and you're passing this down into the consistency model. And that's ultimately going to produce a chunk of JSON, this 5-elemented thing to throw around the network. So let's look at how we get some JSON. And I'm using one of these new libraries called micropickle. And I should come clean first and say we don't actually send a wchar raw around the network. We actually wrapper it in an operation, which just signals whether it's an insert or a delete. So we send an operation around the network. And micropickle has a very simple interface. If you have an operation from somewhere, you just write it, and that gives you back a string representation of that JSON. And when you get some JSON across the network, you try and read it back into the type that you think it should be, and then make use of it. And I want to show this because the actual JSON you get out is sort of reasonable. It might not be what you write by hand, but you can see it's a representation of an operation. That operation has a field, and the fields have various values. The details of that aren't too important. What it allows us to do is use the same format, client and server, and not even think about serialization problems here or consistency of serialization. And if you don't like micropickle, don't worry. There's a bunch of other ones, and you can use shapeless and you can use Argonaut if you want as well. So you've got a lot of control there. Now that we've got some JSON, we can complete our Scala.js Woot client. So we can fill in the implementation. The implementation is just to do the internal Woot stuff we don't want to expose, which gives us back an operation to send around the network. We update our state, and then just use micropickle to create some serialization. And that's really straightforward. And the way this is wired up is in JavaScript. So JavaScript's going to receive this JSON and send it out. So what happens when you receive some of this JSON across the network? And I think this is a little bit more interesting problem. So you'll notice the signature of ingest, it takes some JSON, but it's a unit. So it's got a side effect. So how do you side effect in Scala.js? Well, there are quite a few methods. I'm going to go through 3 of them. So the first one way to affect the DOM is use the Scala.js typed bindings to the DOM. So this is Scala code. And here we're referencing a W3C function that's going to give us back a typed element from the DOM. So you can do that, and you'll get code completion in your IDE and all that good stuff. But that's not what I did in this case. Another thing, I don't think it's the first tool you'll reach for, but you can also make use of JS Dynamic. I think this is, I'm showing you this because I think it's important. I think of it as a escape hatch out of Scala.js. If you ever need to, you can reach out into the JavaScript world. So here we're reaching out into the global space where I happen to know the ACE editor puts its API. And then I'm making, in green, I'm making a series of ACE editor JavaScript API calls. This is going to compile, this is Scala, this will compile to JavaScript and run. But obviously, if I mistype the name of one of those methods, it's going to compile and fail at runtime. So it's not, you know, it's not something you'd reach for, but it's an important part for me because it seems to suggest I'm not going to be able to paint myself in a corner with Scala.js where I just can't do something. I can always, you know, go out through this escape hatch. So that's available, and I didn't do that either, though. What I ended up doing was writing a JavaScript function. So it doesn't really matter what this function's doing, but I have you know, my legacy JavaScript file already. It's got my editor in it. So I'm just going to put in there a function to call, going to pass in a character and whether it's visible or not, and let the JavaScript function, you know, make the ACE editor calls it needs to make. So to use this, what we want to do is pass it into our Scala.js code. So just to position this for you, we've written some Scala code, we've compiled it to JavaScript, but it's going to also accept as an argument a JavaScript function. I think this is the heart of sort of really great JavaScript interop. So let's see how that works out. This is how we use it on the client side. Create a Woot client, pass in the JavaScript function. So we need to receive that, so we can work through this quite simply. Our client class is going to have a field. That's going to be a function that takes two arguments, string to Boolean, and Scala.js gives you a representation for this. And you'll notice that kind of matches up to the JavaScript function I wrote earlier. So now we can fill out the rest of this ingest method. We get some, remember, we get some JSON across the network. We're going to use micropickle to turn that back into a class that we know about, so we can write the rest of our code in using the types we know and love. And there, the implementation is straightforward. We go off and do some Woot, the internal Woot stuff we don't want to particularly care about, update our state, but then we can just match on this sealed trait of operation. We can say, oh, it's an insert op. Okay, I'm going to call the JavaScript function I was passed with, you know, my character turned into a string, you know, to be JavaScript friendly. And this is, I think, I've not seen JavaScript interop as good as this in other languages yet. So we've taken, this is Scala code, this compiles, this type checks, and we're passing in a lump of JavaScript. I think that's just a pretty remarkable thing. So that's part of the Woot algorithm, sort of dealing with data types and, you know, affecting the DOM. What about the rest of the algorithm? I said there's like 200 lines of Scala code. So I don't expect you to read this. This is a kind of chunk of it. And I just want to say that this is using all sorts of things. It's using tuples and pattern matching and guard clauses. It's using tail recursion, you know, traits and methods and maths and the collections library. And I had to do absolutely nothing to make this work with Scala.js. I didn't have to go, oh, I better not use that or this. By simply wrapping this into the client, I didn't have to think about Scala.js at all. So to recap on what we've seen here, it's this, we've been through this kind of multi-project build. Oh, there's a question.
About the case where you used a byte, you got a compiler?
Yes, that's correct. So the question is, when in that first example I showed where I used a byte, that would work fine. When I used a char, I get a compile time error. I can't remember what the name of the error is, but basically there are a couple of types in Scala.js which are called opaque, which there's no representation in. Yeah, it's a compile error, so that's a good thing, right? We like compile errors. So the multi-build project, which you can get by, and we wrote some Scala code which will compile to class files and to JavaScript, so we can run it in both places. And we've seen some really great interop between. Well, we can call JavaScript, we can get called by JavaScript, we can pass functions around. And if we really need to, there's this kind of dirty world we can go to and reach out into JavaScript global namespace. And there's these cross-compiled libraries. So there's more detail to this, obviously. So there's a GitHub project you can go check out, and you can clone that project. And SBT, the more I use it, the more I realize it is actually pretty damn good. So it'll realize you can run the server, and it'll realize it needs to go off and compile your JavaScript for you. And then you can open up your editor and have some kind of big collaborating text editing party that you've been waiting for. So that's the kind of the mechanisms of it. You've seen some of the kind of, I've tried to show you how some of these ideas work out in practice. I'm going to just step back just for a minute and talk about the benefits here. So you do get IDE support. You do get completion on these type bindings, which I know is a good thing. And you get this kind of single language to write in. I mean, in and of itself, writing in a single language isn't terribly interesting to me. And the IDE support isn't terribly interesting, but they are real benefits. And the whole thing about writing an algorithm once and using it straight out of JavaScript, I still think is kind of magic. But when I think about what the kind of underlying benefit is, when I ask myself this, the kind of answer I get is it's all about the types. There's, not only from the point of view of the compiler, checking things for me and making refactoring easier. It means you can think in terms of types. You can think in terms of the constructs you know. You can, follow those type signatures in developing a solution, not have to think, oh, wait, oh no, in JavaScript land I need to do something weird and different. And this, I think, is the main takeaway for me. And the reason I like it so much is that it kind of makes change easier in a project. And if you want to try any of this out, I've got kind of two ideas for you. The first one is just to try and gradually introduce Scala.js into a project. And obviously, CRDTs and these kind of data types are really well suited to this. But you may find within your projects there's a piece of code you'd either like to have client and server, or you already have in some messed up form client and server. And that's a great place to start to sort of rationalize that down into one implementation, one set of tests if you can. And then also I think that's a great fun. So I hope you get a chance to take a look at Scala.js and try some of this out. And with that I'll say thanks. So we need to be out in about 10 minutes. Actually, so there are some questions. Sure.
I have run this demo on the Scala.js site you talked about.
The tutorial. The tutorial. Yeah.
Yeah, the tutorial. And then when I opened up the generated JavaScript file after full implementation, if I remember correctly, it was still kind of readable. I would expect it to have, be a match, just to be very optimized. But it seems that it takes out everything that it needs, but it's still readable, in quote codes, and contains lots of space. So is there a room for further optimization, or am I missing here something?
Right, so I don't know if you all caught the question, but just a comment really that the output from Scala.js is kind of reasonable, and is there scope for more sort of making it more unreadable but more optimized? Is that kind of, yeah. So I think what we, so it goes through the closure compiler at the moment, the final output. So I don't know whether it's the nature of that compiler which keeps it in a reasonable format or not. But what I suggest we all do is head to Sebastian's talk, which is next. And I think we can really get him to show us the source code, maybe, or something. That might be. Okay, there's a question over there. Yeah.
So, I think it goes to the compiler to a file after the. So it's.
Yes.
Not actually going to be what you saw. It's going to be optimized after that.
Yeah. Sorry. So I showed you the output of fast.opt.js earlier, and there's going to be further optimizations after that. Yeah. Is that? Sorry. That was the comment. Okay. Cool. Any others? Or,
I'd just like to say this is a very good presentation.
oh, okay. Thank you very much. That's awesome. Well, let's linger on that for a while. No. That's, so there's a question at the back there. Do I have any experience with React? Oh, no. I don't actually. There are bindings for React. So that means you get to write Scala code and talk in terms of sort of React's kind of primitives. I've not used that yet. I'm currently working on porting a Angular.js app to use more Scala.js. So I'm currently in that world. But it does exist. The best place, actually, to find out more about Scala.js, the mailing list is there. That's a really good place. But it's quite low frequency. You should get onto the Gitter room, I think they call them, not channels. And that's, there's quite a lot of people there, and it's, fairly busy, like 100 messages a day or something like that. So just jump on there, I think, and ask for pointers. Yes, sir.
Is it possible to put the resulting JavaScript into namespaces to avoid name crashes with other teams?
Oh, yeah, good point. Yeah, so it goes into, it does follow your package namespacing. So that's something. But if you wanted to customize that into some other way, yeah, I'm not sure. I'm not come across having to do that. But it does have a reasonable, it does honor your Scala packaging structure at least. Yeah.
Yeah, I had a question about one of the benefits, as I understand, of Scala.js is that you can write code once and use it in both places. I think this is the most important one, at least understood from you. So the question is, if you don't need to reuse your code, is it still worth to use Scala.js?
If you don't need to reuse your code. So if you don't need to reuse your code, is it still a good idea to use Scala.js? So, I don't think it's a good idea to rewrite code. I think that's not a great use of time, particularly. But if you like types and you like thinking about problems in terms of types, I think it's a really good idea. And like I say, there are some really impressive demos. Search around on YouTube or the videos from the last Scala days or the last Scala exchange, and there are some really nice demos of writing a whole program in Scala and running it in the browser. Yeah. Yes.
Is it possible to use
Uh,
no, I forgot.
okay. When it comes back to you, there was another question over there. Oh yeah, debugging. That's a good point. I don't do a huge amount of debugging. So you do get, that's not because I'm great or anything, it's just, you do get source maps, which I think probably is the answer you were looking for. Yeah, okay. So that means you can be debugging in your browser and you get to view Scala code. Okay, sure. Yeah. Yeah, so is there a way to test the client with like a virtual DOM? So I think the answer there is Phantom.js, I think, is what you need to use there. Okay, so I see some people nodding. So the people who are nodding, help this guy out with understanding that. Yeah, but I think that's the solution there. I don't think Scala.js brings lots of new concepts for testing, other than being able to write Scala, which is actually a pretty big one. But I think it's, being just a Scala to JavaScript compiler means it should fit well with other tools. Sure. Yeah, go for it.
For JavaScript, why you should use it. I don't like JavaScript because of the many ways you can formulate the problem. I rather have one way to think, and I chose for Dart. But Dart's great. It has your dynamic and static typing, so if you like dynamic, you go dynamic. If you static, go static. But if I see how JavaScript Java.js integrated JavaScript into the language, it's done even better. So, you go through a lot of hoops in order to call it, it's possible, but here it just goes in like that. The integration is good.
Yeah, so I think that the comment there was that the integration between, the interoperability between is good. Yeah, I think that's one of the main, for me, that's one of the main selling points. Yeah, agreed. Your questions come back? Yeah, okay.
It was, is it possible to use web workers directly, so that are they translated to threads somehow on the server side?
I think no. I don't. Actually, I don't know about web workers. I'm not going to ask that. But just on a related point, so you can use futures as well. What's interesting about futures is not the future itself. It's the execution context. And Scala.js does provide a couple of execution contexts. One which is just run it now, kind of, and the other one is kind of puts it onto the event loop with like a set timeout. So there are. I don't know what the situation is with web workers. I'm sorry, but Gitter channel is the place to go for that. Yes.
Do you think this is appropriate for developing client-side only components with complicated logic like WYSIWYG editors?
Well, I mean, it's not a world I live in, so I'm not sure. Actually implementing the components is something. I mean, I don't see any reason why not. You get access to the DOM, you get dynamic stuff. I don't think there's anything you can't do. I mean, I'm very impressed with Scala.js and what Sebastian and the team have done there. It seems very reliable, so I wouldn't think twice about trying it at least. So yeah, do give it a whirl. Okay, I think we're sort of getting near out of time. Is that we're good, or is that we should go? Oh, we're good. Oh, okay, cool. Yeah, sure. Let's take another one. Yeah.
It seems to be quite important that you have somebody develops bindings for common libraries. So I see that jQuery is obviously the highest template and has already been implemented. Is there a recipe for communities how to do this quickly and to adapt the most important?
Yeah. Okay. So the question's about developing those bindings, and it's a really good point. Because there is some effort involved in doing that, and I'm really appreciative of the people in the community who are going out their way to do this. So what I should have done, in fact, is develop a binding to the ACE editor. That's what I should have done, right? That would have given me more seamless interop. The solution I came up with, actually works fine for me. In terms of a recipe, I'm not so sure. And there's lots of examples to go look at and see how people have done it. Is there? There will be some documentation on Scala.js.org. On the top right, there's a section called Pages, and under that is all the knowledge there is, and the Gitter channel as well to get some feedback on what you're trying to do and get some help from people. Sorry, yeah, please. Bindings for free, did you say? Oh, yes. Yeah, so TypeScript have done a lot of work of already figuring out the appropriate types. So yeah, people have been, they're open source license, right? So they've been taking those ideas across, I guess. That's cool. Okay, I think we should maybe wrap it up now. Thanks again. I'll try and blog a bit more about this stuff on _.io.